So we're going to be talking about Pi. Pi is a harness. I will try to keep up with what you guys are doing in the chat. Hello, joining in muted. If you have questions, leave them in the Hangout chat. If you have notes or anything that you might want to explore, you're also free to unmute at any point, and I encourage you to do so. We're going to talk a bit about agent harnesses. So harness, agent harness, let's see. All right, we'll just talk a bit about Pi. So Pi is an agent harness. It is a code base that is about 50 to 70,000 lines of code. I saw somebody unmuted. I'll quiet down. F3DZ. Okay, you're done. So Pi is an agent harness. It runs in the terminal. We're going to launch a ghosty terminal so that we can keep up with it. And do Pi update. But there are apps that let you connect Pi. So I'm not really sure I remember which ones, but you'll definitely find a few here and there. Let's change to OX 0x. I'm not really sure where that is. We'll try JLM 5.2 just so that we can follow along. So this is a terminal. Ghosty is a terminal. It can do multiplexing, so you can do something like Control or Command D to open another terminal on its side. Command Shift W. Okay, I don't need Command Shift W. Command Shift D. Okay, that just keeps making new sessions. But each one is a JavaScript process that's running on your machine. It provides 3 layers of modules. So modules in this case, imagine them as like components of the system. There are 3 of them, and they're layered. If we go to the code base, so you see this is the Pi code base. There's packages. It's a monorepo, so that means there's multiple repositories in this one GitHub repo. Once we get in, we see all of these are different. Packages that could be used on their own. The base of all of them is AI. So AI does all the translation between different providers. If you look at Anthropic, Anthropic usually serves their models with v1/messages. So it's their Anthropic API. It's different than the OpenAI API or the Responses API. So if you were using Claude and then you tried to switch to GPT, you would have an issue because these 2 models speak different languages, basically. So this is the basis of the entire repo. It's the heart. And I think it's like very easy to understand. It's really clean. There's not much code. And you can pretty much get a sense of what's going on by just looking at the shape of things. This is a lot of documentation, but we can just jump in. Let's see, session resources. You have index. Index is usually where everything is imported and then exported out. So imagine like this just has all the wiring. This is the wiring of the app. And by following the wiring, you can see essentially what imports what. You can see all of them. This pretty much covers like 95% of the AI market in terms of like the inference providers. So there's Cerebras. You can see here Cerebras is being imported and exported back out. There's the Cerebras models. They're importing it from somewhere else. But this speaks the Cerebras provider language. So you can use Cerebras in this application. You have the DeepSeek one, and they're all basically the same. They're templates that are being filled. Each template is using this create provider function. If this is a little too complicated for you guys, or you feel like it is not relevant, if you have any questions, please feel free to leave them in the Hangout. So provider this is what everything is like pulling from. This is the base file that providers, that is the shape of the provider. It has all the functionality in here. These are all the interfaces, the types. So when we say models, we know that models have get providers. So a model can have multiple providers, or it could fetch like a specific provider using an ID. Check off, get off, log in, log out. So it's implementing all of these functionalities that when we do login, this is what we're hitting. We're hitting the code that's in here. And login is a function. Somebody unmuted? All right, we'll continue. So different providers, like Claude platform is the Anthropic provider. They speak different languages and they have different subscriptions. They have different authentication methods. All of that is being handled within this package. all that is being handled here, so you don't have to. If you're building an AI app, like you are talking to Claude and you're trying to build some app that has some form of AI functionality, these are all problems that you will eventually run into. So it's a good place to get information so that you can apply it in your own products and your own projects, or you even just pull in Pi and use Pi as is. So we talked about providers. Providers are like Claude or OpenAI or Cerebras, your own personal provider, as in you bring local like Llama, CPP, or whatever into Pi. So they have a limited amount of VRAM that they can give, and VRAM stores three main things. Obviously there's other stuff happening on the GPU, but these are the three main things that are stored on the GPU, or like what is taking up space. There's the model weights. The model weights are all the numbers, the floating point numbers in a certain format that the LLM is. So an LLM is simply, we can look at config.json to get the point. An LLM is like a configuration. This is a configuration associated with a bunch of floating point numbers. So this config tells you what the model is, its architecture is when, et cetera, et cetera. So if you look at the inference engine, VLLM, Llama CPP, SGLang, so the provider, what they're doing is they have an architecture. That architecture has code that does math on that architecture. So that's what is running on the GPUs. And it is linked to whatever amount of gigabytes of weights. When you see the number 27B, that means 27 billion parameters. Each parameter, if it's in 16 bits, which is what most models are published as, if it's 16 bits, then it would be 2 bytes per parameter, which means 27 billion parameters is going to be 54 billion, 54 was it? Yeah, 54 billion, 54 billion bytes, which is 54 gigabytes. You can see like the model, like basically, okay, this is the performance, this is the benchmarking, but this is all the code for the inference for the different providers. We're going to go back into Pi. The agent loop is a for loop. So if you've done programming, you know a for loop is just keep doing something until some requirement is met and you break out of the loop. So the for loop in this scenario is a loop, just like we know. And the exit condition is the model outputting the I'm done token. There's a special token called a finish token. So once it outputs finish, that means the turn is done and the model output has been provided and it is waiting for the next prompt, is waiting for the next thing to do. So the way that the loop happens is there's like an outer orchestrator script that is doing the looping, that is forcing the model to look at what it did and continue doing what it needs to do. And then there's what's going on inside the model. So the model is what decides when things are done, when it's done and it needs to stop. That's how it outputs a token. And usually that's based on its training and the trajectory that it's going on. So what I mean by trajectory is when you give it a task like edit this video for me or write this code for me, there is a statistical probability or set of statistical probabilities where it's going to do some stuff to try to fulfill the request that you've given it. And as it's doing that stuff, eventually it feels like it is done. So it's like it's run its course and it says I'm finished. And that tells the outer loop, which is Pi agent, that the turn is over and we can stop. The agent handles a few things. So it handles this flow, agent start. So we've sent the prompt, turn start, the model has processed the prompt, message start, it starts writing or like it's reading your prompt, message end. Okay, message start for the model starts responding, it emits a stream. So what we see also is a stream. We're not getting things in chunks, we're getting things in streams. That's why you see like it's filling bit by bit the sentence over and over again. So that's the streaming that we need to handle. We need to take that stream, which has an API structure, and we need to turn it into a format. Here we go. So this loop, this agent loop, it's doing things as the model is emitting data. Some example of data is it emits a tool call. A tool call is something like, let's look at an OpenAI tool call. API. So imagine this. This is like a tool. This is the description of a tool. It's get inventory is the name of the tool. You have a description, parameters. So that's the stuff that you give in the code when you say get inventory. Like maybe you are getting inventory for a specific item that you're selling. Which models work for free in OpenRouter? I tried JLM 5.2 for free, but it throws an error. find what works. There's a free API. And yeah, you can basically filter for free models on OpenRouter. Let's go to OpenRouter. Let's go to models, and where's prices? I can't find the prices. Okay, there you go. We want free. So I would recommend this one, but there's other ones as well. Let's go back. So if you guys want to play along and you don't have like a subscription or you're out of your sub, you can always use the OpenAI free API, so the OpenRouter free API, and it'll just give you the best model for the task that is free. Um, and it's always free. There's always like models in the free tier. Obviously, they're dumber, but they can still get the job. Okay, so we're gonna go back to the tool. So tools are the last big part of this. Uh, Let me think how I should explain this. Yeah, so you have the model that's looping, and it can take text in and push text out. But then you need it to do stuff. Otherwise, like yeah, it's just yapping. So you need to give it access to tools. And Pi thought we should give it access to 4 tools like read. So I think it's bash, read file, write file, and edit file, and that's it. So the model can do 4 things, and then everything else is a derivative of those 4 things.
I have a question.
Go ahead.
What's when you're adding new tools, is it something that you would just essentially ask the LLM to add for you, or to add them in manually? Like, what's the process to add in new tools?
Okay, so if we're talking about like writing and creating your own tools, you have this API format, right? That says this is like what the tool, this is what the tool takes in and what it spits out. Here's who's allowed to call it. Here's type of the tool, the name of the tool, the description. So this is a schema of what your tool takes in and out. Now, this would be associated with a function, some code that does something when get inventory is called and all that. So the thing is, the models are great at writing code, so they can write tools and they can just throw them out. Like you don't need to have them forever or carry their weight. The model can write some code, like call that code, and yeah, it does what it needs to do. So Pi is giving you the bash tool, and bash is so bash tool Pi. So bash is like just this catch alter like tool that can do pretty much anything that you can do on a computer in some way or form. It's not perfect, like it's very general, so it's like it's a very loose tool. It's hard to collect information and data on like how it's being used and all that, but it's like a hammer. You kind of need it. So it uses bash to do everything, and then it creates files, which files could be code in themselves, and then it uses bash to call those files. So Pi again, it handles the loop, which is until the model is satisfied, keep going and keep outputting tokens. The model decides when it's done outputting tokens, and it says finish. That means that the loop is cut and it's ended. Um, During the loop, it has access to tools. You define the tools that it has access to, or you just use a harness that's already pre-made like Pi, and Pi tells it you can create files, edit files, read files, call bash. That's pretty much all that you need, and you have an agent. Let's see. So it's telling me, okay, so there's 5 create goal. Okay, I gave it the create goal tool. So I gave it a custom tool via the extension. Um, yeah, plugin, I think. I don't know how you get to it, maybe in settings. But the tool is called Pi Goal, and it's just goal from Codex, but in Pi. So you can do goal, and you can say, like, I don't know, something like find all of the sessions that I've had with Codex over the last 2 days and summarize the whatever I did, wherever I got stuck, what's still pending, and what I need to do next. So I give it a goal, and then it just sits there and works until the goal is complete. It just makes the model run much longer, is essentially what's going on. But this is using a local model. So we go here. This is GLM 5.2 that I'm running locally, but you can also run Quen 3.8 27B. Probably most of you can run this model. Um, it won't be at like its smartest, but it'll probably run for most of you in some way, like 3 bits. But I'm using local models right now to do the coding, and it's just like finding all of these sessions. Uh, so hopefully that explains the tools part. So you have an agent loop. There is a cache. The KV cache is the history of the conversation. If you fit the history of the conversation on VRAM, so video memory, which is GPUs, or let's say mixed memory cards or DGX Sparks, if you hit, you can store the KV cache on memory, and it'll be very fast to process tokens. To do prefill, prefill is when it's reading your prompt. When you send it a message, there's like latency, and that latency is because the model is moving the bits onto the GPU and doing all this math to derive all of the tables that it needs for the matrix multiplications. So if there is no cache of that existing already on the card, it's going to have to recompute all of that, which is very math intensive, which takes time. But you can have the KV cache on VRAM. It's heavy, and VRAM is very expensive. So there are other solutions like LM cache. So LM cache takes that KV cache, which is very valuable because it's all of these like histories of your conversations, and all the math that was derived through that conversation. It splits it into small chunks and it stores it either on RAM, but that doesn't persist. So RAM is like DDR4, DDR5, any like DDR3. Then you have also NVMe, SSD. So you can store the cache on different parts of your computer. The slower the memory you store it on, the longer it takes to verify if that cache exists or not when it is running. So if you are sure you're going to hit the cache, like if you have a harness, like you're using Claude Code, it starts with 30 or 40,000 tokens already in the cache. And those 30 or 40,000 tokens are hot, so they're always loaded in memory. You can put those on NVMe, and fetching the cache when you send a prompt is going to be pretty fast because it knows it's there, it knows where to get it. Pi is very good at protecting the cache. It has one of the highest cache hit rates among all the different CLI tools. So I recommend it if you're trying to save on tokens. You can plug in your Codex subscription. It's free and open source, and it's the basis of the app that you're looking at. So this is my app for running local models like Local Studio or what is it called? LM Studio. And so when I say hi or whatever, this is going to Pi. So I'm running a Pi process associated with this session. I personally have been using my own app and then Codex, Claude. Do I use anything else? Zcode as well. I like the desktop apps. They take up more RAM, but they make it easier to scale like my usage because I can see all the sessions flattened out. I know there's stuff like Herder, but it just takes time to adopt things. So right now I'm using the apps a lot. Okay, let me see what's next. So we talked about providers, OpenAI, Anthropic, whatever. We talked about tools, how you format a tool, how you do the tool call. We talked about the agent loop. We talked about the translation layer, which is the /AI repo in Pi. And that covers most of it. There's coding agent, which this is what adds the TUI. So the TUI is the terminal user interface. It also adds like a few more things. So extensions so that you can extend the model's capabilities without modifying the core code that is very clean and simple. And yeah, I mean, I think that covers most of Pi. I will open it up to questions or any kind of, yeah, if you have any questions, let me know. I'll just leave quiet.
How does it handle like sub-agents? And if you want to maybe use a local model and delegate to like a cloud model?
So because this is a terminal process, it has like the TUI, the terminal user interface. There's also an SDK for Pi. So if you were trying to do anything complicated, you can use the SDK. Also, all of the conversation, the session, is just files. Like the history of the chat is JSON files or JSON-L files. So you can actually fetch all of that out. But to answer your question, because it's a terminal app, the model has access to Bash. It can use tmux to spawn either a headless or a headed version of Pi. So it could just like spawn itself again. And because there's all these models from all these providers that we saw how like the providers work and the models work and the logins, the model can call its like harness. So it can say Pi run, let's say Opus for 5. I'm just throwing words out there. But that will run Pi in the terminal that the original Pi has access to, and it'll be emitting a stream, and that original Pi can read what it's saying. That's a little bit complicated to think about, but just imagine like it can do what you're doing. It can prompt itself, and then that next prompt is its own thread and its own history and its own thing. Any other questions?
Hey, sorry, I joined a bit late, so I probably missed a couple pieces there.
Hello,
Curious.
Fran.
Hey, Zero. Nice to talk to you again. Curious if you did any comparatives. Like, I'm curious as to why everybody's so excited about Pi, and if, like, you can give a high level differentiation to something like, using Codex or I don't know, other harnesses?
Yes, so there's a few reasons to use Pi over other things. One is if you're a builder, if you like to build stuff, Pi is such a great building block. It's very small lines of code. Like I think the whole thing is maybe 50,000 lines of code. The core is like a few thousand lines of code. Most repos these days are in the hundreds of thousands, if not millions. So that helps a lot. Let's see where Deep Suite, Terminal Bench, where's Pi? Agent. I don't think it's showing all the agents. Pi agent benchmark. So it's a great building block. It's very lightweight. It works great. Let's see, Pi agent. So I'm gonna have to find some benchmarks and leave them in the server. I've seen a lot of them. Also from my experience when I've ran, let's search my Twitter. Pi. It has the highest cache hit rate, which means it's the cheapest to use with the same models. Like so this is an example, median time per task between Pi and everything else. So Pi doesn't have a large system prompt. Its system prompt is 400 tokens. Claude Code's system prompt is 20,000 tokens, which is whatever. Now that models have 1 million tokens, sure, but there's a smart zone as well. So the smart zone is the more tokens are in the context window, the more unrelated stuff the model is doing math on. So if you're talking about coding and there's some reason you start talking about, I don't know, some research paper, now the next probable tokens are going to be tainted with this external information that is irrelevant. So the system prompt is very often irrelevant and it adds a lot of latency. So between the fastest and the slow, so Claude Code has the slowest hardness because it has the largest, which I think it's actually 34,000 token system prompt before the tools and all this other stuff for Claude Code. So let's say you do 12 prompts, that alone is 1 million tokens that is being processed. Just in system prompts, like you hit the cache and all that. But so it has less stuff in it. It's a great building block, and then it has a pretty smart system where you can tell the agent, like, I want to add this feature to Pi. The agent then immediately has access to the Pi docs, so it can search a specific way of doing something in Pi. It can pull that file, and then it can hot reload. So let's say it adds a new file in the Pi repo that shows you how many tokens or how many dollars you spent over the last day. So that's a plugin and an extension to the main core process, but the core process can just restart itself. So it can add new stuff in it and then restart itself. So it's cheaper, it's faster, there's less stuff going on. It's better for local models because there's less tokens in the context window. And the accuracy on it is one of the highest on Terminal Bench. I think it's like the second or third highest. And obviously it's open source, and the guy who made it is very nice. So the pink is Pi. So I used it a lot. But the cache hits, so the cache hits are like the barred out zone. So that's the cheapest possible tokens you can get. So from the same, like even if I'm using Codex, those cache hits are much, much cheaper, 10 times cheaper than doing regular prefill the normal amount. So you can see that it has the highest cache hit rate by a lot. All right, so Oh My Pi is similar. Let's do OMP update. It is Pi under the hood, but it gives it all these extra tools and all these extra functionalities and features. So it's like a good view of the future. What this harness does well, it's pretty cool. I don't know why I have to restart it, but it's pulling all my Pi stuff. There you go. Model. So what this thing does well is there are different roles for models. So there's a vision role. A vision is imagine you use GPT 5.6 Luna for vision. You're getting it off your Codex sub for nearly free, and then you have a local model like DeepSeek V4 Flash that doesn't have vision. So you set DeepSeek V4 Flash as the main model, and DeepSeek V4 Flash is the main model. The vision model would be Quen or whatever it is that you want to use. You have the idea of an advisor. So the advisor reads all of the tokens that are being streamed to the model that you're using. And it has your original prompt. It just interjects the main thread if the main thread starts going off track or doing something irrelevant. So it stops, like you can set a local model as the main model. You can set 5.6 Codex as the advisor. And then the main model is doing its thing. And if it starts veering off or speaking in Chinese or whatever, the main model sends it a message, a prompt, and tells it, stop doing that. You have to actually do this instead. Or if the main model is like done, it just decides it's done and it actually isn't done with what you asked it to do, the advisor can just kick it back into gear and tell it you need to do X, Y, Z next. What are all the features? So there's one request that is live. It is in prefill. So that means it's in prompt processing time. And you can see here, it's like reading about OMP. By looking at the package, it sees the session. It sees like what the providers were using, the models. It's just reading this stuff. And it reads its own memory. There's like a memory system. You don't have to use this, but this is the point I'm trying to make is this is all Pi under the hood. So you can have a super stripped down like Vim type experience, or you can have this rocket launcher bazooka, burn as much tokens as possible to get to a solution experience. And it's going to be the cheapest you can get it because of the high cache hit rates, the optimal performance and all that. And vice versa, your local model could do great at being like an assistant and telling you what you need to do and all that. And then spawning frontier models, or you can escalate.
I actually have a separate question, if you can hear me.
Shoot, yeah, please.
So what is your actual sort of perfect long form task setup if you want to deploy, frontier model as an orchestrator, but then also involve your local LLMs to do some of the work? How do you make sure that sort of a long run task is done? I'm guessing it's a goal, but then I'm assuming you also have some validation loops in there. Sort of what's the perfect structure that you found?
Yeah, what I do is, so there's a platform called Zcode. So I have Zcode, and it is like similar to Codex, but you can bring in your own providers. So if we go to, let's see, where's the model settings? You can bring your own providers. You can just keep adding more and more providers. So you can set your local models up. You can connect your, let's say we do responses, and you can set up your subscription to OpenAI and all that. And then you can set goals. In this app, a goal is an automation. So if we go to automations, we see these are goals. So every X period of time, if the model isn't doing something already, the automation kicks in and sends it a prompt and tells it you need to keep doing whatever it is I prompted you to do at the start. Then, I'm sorry, I'm just trying to think. Yeah, so then I tell it to use tmux. So tmux is a terminal multiplexer thing that lets sessions stay alive in the background. So tmux, it can just spawn another, like, so Codex can spawn a bunch of Pi agents that use my local models, or vice versa. And I just have them do hill climbing. So hill climbing is where you structure the task in a way where there's some verifiable, like reward isn't the right word, but like there's a verifiable metric at each turn end. And then that metric acts as the start off for the next turn. So let's say a hill climbing task is make this local model run faster. I don't really care how you do it, just make it run faster. And don't stop until I come and stop the loop. And you set that up, and then it has an automation that runs every 30 minutes. It tries to make some change. It tries to install some kernel or like write its own kernels or whatever it does. And then it runs again. And if it hits a higher score, it updates a GitHub repo that then other people are using, if that makes sense. So I structure most of the coding work now as these never-ending cycles. You could do the same with like app development by saying, use the app. So here's like a catch-all prompt. Look at all the code in this app, figure out what everything is doing, write down a list of features that we support, use all these features with browser use, computer use, then note down if there's any bugs or any unexpected outcomes under these specific features that we've outlined, and then fix those features, then run the thing again, right? It burns tokens like crazy, but it does make a difference. How to evaluate harnesses for our own tasks through different harnesses. This is a great piece of advice that I heard from Theo. So whenever you are doing work and you have a task that was really hard to get done, like where you struggled, where Claude was like going in circles or Codex was going in circles, save that session somewhere, because that is going to be a benchmark for your local models, for your whatever new frontier models that you're using. It's going to show you if capabilities are improving and if the workloads that you have that are difficult can be replicated with local models. Does that answer your question? Feel free to ask one more question, guys. Last one. I see someone typing. Once they finish, we'll answer that and we'll head out. What you should do after this call, if you want to keep learning, is to read the code. So I'm going to mute this because it's a little loud, but read the code. That's pretty much it. Like you'll get a huge amount of understanding of what's going on. You can have the model support you in reading the code, but try to read the code. It's going to help you learn a lot faster than send you the repo. All right. I think that covers it. Thank you guys for coming.
Thank you so much. Appreciate it.
Thank you.
Have a good rest of your day.